Thanks for coming. I want to try to make this very relaxed and make it more like an interaction between you and me, because I don't like to try to lecture people. This is a community effort. We created this out of a need and a drive to share with the community. Around 3-4 years ago, I was working at HackMiami Technologies in Fort Lauderdale, and one day I got a call from some people in Silicon Valley, and then they told me, "Listen, there we go, right on time, man." Come on, ladies and gentlemen, this is my partner in crime, Joe Sedan. Okay, hey. So he and I, we worked together, and we came up with this project. Basically, like I was saying, I was in HackMiami, and then somebody called me and said, "Hey, we got this thing called machine learning." I was like, "What?" Okay, this was like 4 years ago. We're not sure if this is going to work, but I think we can give it a try. And I said, "Well, that's great." So I flew to San Francisco, Silicon Valley. I went to Palo Alto. And then for the next 2 days, today. So every person was more intelligent than the other. I mean, I've never been in front of so many brilliant people. And then finally, was Madhu Sudhakar, and then Madhu convinced me to basically leave HackMiami and then go to Silicon Valley, which is what I did. And then 4 months later, we were acquired by Splunk. So Splunk bought Caspita for around $190 million. After that, I was at Splunk for a year, 2 years, and then I was contacted by a very clever and hacker as well, called Greg Martin. And Greg Martin is the CEO of JASK, which is our current employer. I don't know if you know Greg Martin. He founded Anomaly. He has done a lot of open source projects and modern honeynet network. That's one of his projects. So it's interesting when you're interviewed for a job and the guy that interviews you says, "Have you ever used this?" And I'm like, "Yeah, I have an actual honeypot network." He said, "I created that." So once I heard that, I'm like, damn, I got to work with this guy. So basically, what you're about to see is our way of sharing with the community. A lot of these technologies are being used in Silicon Valley. Right now, a lot of the actual dynamics of the backend platform have changed. Back then, it was like Hadoop, very heavy on Hadoop. Some people call it now Hapoop. Because, we had seen that Hadoop has had a lot of pitfalls. I can give you a little bit of one time an experience. I was in a very, very, very large company, probably the largest company in the Seattle area. It's a software developer. And they were testing, we were doing a proof of concept. And I remember we had, I think it was 32 or 64 nodes, right, of Hadoop. Every machine was like 1 terabyte of RAM, right? So this is like the biggest you can go on Earth, right? This company has unlimited resources, their own data center. And the people that were supporting were PhDs that contributed to the actual projects that we were actually trying to implement. I mean, you can go higher than this. And Hadoop will crap out. I mean, there were errors everywhere. And I think that was the day that I said, maybe Hadoop is not as good as we all think it is, right? Obviously, if we're going from a simple relational database to Hadoop, there is definitely an advantage. But things have changed. Nowadays, what is being used mostly is, say, Spark. Kafka. But things have evolved. Back then also, one of the things that, if you are in the industry, you know there was a lot of hype on machine learning, right? And at first we used to throw, basically that's what we're doing, throw in algorithms to everything. So there's an algorithm for lateral movement. There's an algorithm for C2. There's an algorithm for beaconing. There's an algorithm for brute force. And then we realized that the algorithms at times were applicable, and some other times were basically signatures on asteroids. That's what they were, right? So what happens? You learn that the adversary eventually defeats the algorithm. The adversary, you're fighting humans, right? Humans will learn, and they will figure out eventually how to overcome and defeat the technology. So us working in that context and with all those technologies, we thought, hey, what are the chances that we can come up with a tool that can be used at home and we can share it? So we talked to Greg, which is he's very community oriented. So we decided to come up with a way of creating a framework that was user-friendly and that can be placed into hopefully a Raspberry Pi. I'm sure that question will come during this talk. We try. By the way, the Raspberry Pi is not there yet, and you're going to see why, right? And also, we had two other open source tools that had been presented at Black Hat Arsenal. And actually, I can show you. It's right here on the GitHub, which is called Acteon. Acteon is basically, we did a Java version, and then we did a Python version. The Java version was basically coded in Java, but the binary was too large. It was around like 150 megabytes binary. So we said, why don't we just port it to Python, which we did. And what Acteon does is basically you feed it a PCAP, it uses Bro. From Bro, you're about to see the architectural diagram of that. And then from there, it applies a number of algorithms and tells you there's the likelihood of exploit delivery. And the likelihood of exploit delivery, it's based on calculations on things that we call microbehaviors. And microbehaviors for us are the tiniest unit within an exploit change that you can, I guess, is divisible by. We will explain further in a minute. So we thought, okay, can we bring this home? Can we make it home? Is there a case for this? Oh, sorry. Is there a case for this type of technology at home? And then we figure out, well, basically what you have at home is a very simple infrastructure, which consists of a CPE, which is a customer premise equipment, which is your router, and then you have an access point. That's pretty much it. And that is a Wi-Fi access point. And then what you're seeing here is basically examples, some alarm, which at this time was incredibly cool. And then I think, is that some alarm or Black Eyes? Anybody remember Black Eyes before ISS bought it and destroyed it? No? Okay. Huh? Black Eyes, right? There you go. Okay, here we go. So Black Eyes was the coolest firewall back then. And then IBM, ISS bought it, and that was it. So we decided to, based on that, we decided to look at some of the the tools that are open source that were available at the time. And then we decided to give it a shot. So we said, okay, what can we do in order to put this into a home environment? And what are the conditions that we're going to have to face in a home environment? So here's some of the things that we consider. First of all, Internet of Things. So we had toasters, refrigerators, thermostats, cameras, wearables, AI. You have Google Home, you have Alexas, and then you have routers, printers, all kinds of devices that connect to your Wi-Fi. That's where we decided that we needed to be at. We decided that we needed some visibility into this area, which, in our opinion, there are some products, you're probably aware of them. There are little boxes that then they basically work with, send the data to the cloud, and there is a backend that processes it. we wanted to do this for free, and we wanted to make it affordable and easy to use. So another of the variables of these devices is that they usually will go on patch, won't be updated. Not sure if you guys heard the recent GPON routers that were being exploited in the wild. Most of them have sometimes hard-coded credentials, so it's easy to break on them. So basically, the home user is exposed. And they don't have an idea. They really don't have an idea of what's going on. You basically, you connect to your Wi-Fi, you turn on your Amazon, your Hulu, and you watch your movies or do what you need to do, but you have no idea. Somebody might be poaching, might be in it, somebody might be watching you from who knows where. Mostly cameras. Cameras are constantly targeted. So we decided to see if we could tackle this. So here's some of the other stuff that you've probably seen. The spam also happens to be a variable at times, and then obviously Tor. And then we said we're going to bring machine home to to everybody. You know, this is no longer a Silicon Valley elitist, no longer for the powerful and the rich. So we decided to basically incorporate some of the tools that we have, which in that case was Acteon. And you can see it in the code. The code, you can download it. And then we try to make it simple to use. And that's the biggest challenge, believe it or not. The technology is out there. The challenge is to make it useful. And how do I know if I'm successful? When grandma can use it. Right? If grandma cannot use it, I'm not there yet. If I had to explain to grandma how to create a VM and CH mode 777, obviously that's not going to be easy, right? So in order to make it simple, we needed some sort of interface that will speak, right? Something that would say, hey, this is going on. So we looked at different things. We looked at several frameworks that we could have put into use, and then we apply the advantages of machine learning. Obviously, when you use machine learning and you start processing large quantities of data, that becomes a challenge as well. Because, for example, Acteon, when Acteon is running in Chiron, it runs every 4 hours. So what it does is it compares is benign training, which we included in the software, and then it looks at all the URIs that you have been downloading or visiting via Bro, and then applies the algorithm and says, hey, it looks like you may have a problem here. We will show that in a minute. So these are the vectors that we are looking at. In a few slides, you will see the actual architecture that we came out with. We also thought that these other vectors we could address, like high-risk users, domains, assets, data usage, north-south, social media, odd applications, traffic and services, and malicious file downloads. There's a lot of work we really want to do. It's not there, but one of the things that we want to do is we want to put Kismet, and Kismet put it into IDS type of mode. You know, Kismet can tell you if there's a new Mac inside your Wi-Fi. So it would be cool that it will pop up and say, hey, an unknown Wi-Fi device is trying to join your network, or I've never seen it before. And these things can be done. We can code this. The problem, the challenge is, how can I make this affordable to everybody? And how can I make it easy enough for the common user to do it? Also, one of the things that I will comment in a few is that we didn't want you to use a Hadoop cluster, for example. You don't need Hadoop in order to use machine learning. There are certain machine learning frameworks, mostly that have been ported to Python, that we can use. You just got to be careful sometimes of what the extent of it is. We didn't want you to think that we're just giving you a bunch of BS, so we posted the code. And with the code, sorry. And with the code, you can look at the code and say, hey, you screw up here, this is not true, this is bad, blah, blah, blah. I mean, that's it. I'm giving you everything. So, in fact, I can tell you a gentleman in India, Chiron, which is one of the tools that's included into this, he coded it into, C++, right?
Senior project is C#.
He turned the entire framework into C# and added, I think, TensorFlow.
Yeah.
And he added TensorFlow. So we have a version of that as well, which is awesome. That's exactly what we wanted. So one of the biggest challenges of a home is that you're sort of segmented. You have a CPE, and then you have a access point, and then you have like two networks, right? You can have only one if you're just using Wi-Fi. Nowadays, most of these laptops don't even come with Ethernet jacks anymore. But we thought that the whole concept of a network tap was too sophisticated by a common down the street person. So we decided to approach it in two ways. Let's see if we can. I can probably skip this, and then I can come back to the microbehaviors stuff. But I wanted to show you this. We use a couple of tools. One of them is Bro. So Bro, you need only one interface, and it runs on promiscuous, and it's constantly grabbing data on Bro. We also added a cron job to do Mmap. So every an hour or so, Mmap, we got a script that basically grabs the DHCP allocated address, looks at the network mask, and then, okay, this is what I'm going to scan. So it scans the entire network. This may have issues at times, depending on how aggressive the scan is, because it may affect printers, for example, fragile devices. And then we use POF because it's a passive scanner. So with this, we try to bypass the whole tap. You can, at this point, we haven't found a way to emulate or beat the tap setup, which basically would be the best, where we will see absolutely everything. But telling somebody, hey, you had to use these IP tables and then connect this here, get this other card, connect it here, that's not going to happen. That's not going to happen. I had to do tap setups even for my own job, and go ahead and call Comcast and wish you luck. Right? So this is not easy. And I understand that some of the efforts that this vendors that are trying to sell you these little boxes that you just plug in and plug out, that's what they're trying to do. It's the same idea. They're just trying to make it in a way where you just plug it and then it calls the cloud, right? We didn't want to get into the hardware business. We don't want to get into the hardware business. I mean, everyone that has worked with boxes know that boxes always expire. Boxes can, at one point you find something that makes it vulnerable that wasn't there when you bought it, and then now you need to upgrade it, et cetera, et cetera. So we didn't want to get into the hardware business. We looked at Intel NUC, which is called NUC, and maybe some of them might be applicable for this, but there's still a challenge. And one of the biggest challenges is EOK. Are you guys familiar with EOK, which is Elasticsearch, Logstash, and Kibana, which you will see in a minute. It's basically this. That's EOK. So, sorry?
That's Kibana.
Well, right. But it's Kibana on EOK. Behind this, there's Logstash, and it's basically running on a Linux box, and it's an open source framework that allows basically what you just saw in this diagram to parse all the logs from Bro. It parses the XML output from Mmap, and it parses the POF results, and then we can use visualizations in order to make it friendly, and that's what we try to do. So one of the things that you will see is Chiron will tell you where the active devices that you have. It will tell you where the active ports. Like, for example, I was able to find out that I have an all GoToMeeting client in my house that I had installed for years, and he was still beaming out. And he says, "You have a VNC port open." I'm like, "VNC port open?" I'm like, "I've been compromised." Right? So I will go back to the IP, find out it was GoToMeeting on a Windows box that was there for years. So even for people like me, this happens. Imagine people are unaware of all these challenges. So that's basically what we're trying to do, right? And then we're trying to add things, and I will talk a little bit in the future. But I'll let Joe explain. You want to explain about microbehaviors? Yeah.
Okay, so so kind of like, I think, one of the recaps here is that there's like a lot of cool technologies we see in kind of enterprise grade security systems. One of like the most disappointing conversations I've had with like really kind of high profile Silicon Valley sort of shops and business plans is that they don't see a lot of value in creating solutions for the SMB, like the small to mid-sized business just doesn't have the same target demographic from a value perspective. So like oftentimes I think the techniques we learn kind of in the Fortune 5000s and the Fortune 10s, they're sort of lost on the smaller kind of endeavors, and mom and pop shops just don't get the same kind of defense. So one of the kind of philosophies here is just to sort of share, kind of scale down some of the ideas we see that are real simple and kind of work for a couple like key tactical use cases. I think the number one use case, like the intuition, is that we just want to know when something on our network is different. In a really large environment, this is a really hard problem to solve. Like to ask when a behavior is abnormal for like 50,000 users or 10,000 users, it's a much more difficult problem than asking if a behavior is abnormal on a single LAN segment that you kind of get in your typical kind of home network. So I think there's certain problems that are a little bit easier here. And if we can kind of zoom in the intuition and like what is low-hanging fruit there, that's kind of how this all manifested. We had like an API. I think it was just timing out when Rod was trying to go to the GitHub, but there's links to all this stuff. And the initial API that we'd sort of kind of built at a couple like Black Hats ago was sort of using this language of microbehaviors. This is a synonym for features in data science, or more importantly, from a programmatic perspective, it's a way for us to organize our units of code in like in a kind of programmatic configuration file. And so, where's that? Right here. So, like, you can kind of just, and the other thing is it's about sort of coalescing and having kind of an API that's expressive enough for us to sort of use a signature, a regex, anything we know that's good, that's kind of the low-hanging fruit on the pyramid of pain, all the way up to sort of higher kind of level expressions of adversary behavior that get a little bit more complicated than a single kind of pattern match. So the goal of this sort of API is to be able to kind of have an expressive entry point when we're coding, and so we kind of have this. I think we'll have kind of code samples eventually to show you kind of what this means in a little bit more detail. But examples of like things we're looking for in Chiron are kind of tuned to when we sort of have malicious kind of crimeware running on our environment. So there's a lot of URI kind of properties around there, and computations we're doing with respect to like HTTP. And then the other sets of microbehaviors are really about kind of change point detection. Like, what is new in my environment? Like, what services have we never seen before that are all of a sudden interacting in an interesting way? Like, what boxes have talked to other parts of our network that, like, typically, like, my Nest shouldn't be talking to the air conditioner or whatever else is online that kind of has its own sort of local behaviors. We're expecting those to be stable over time, essentially. And so just kind of getting into the architecture here. So I think there's a few motivations for kind of how we try to kind of borrow some kind of ideas from some very smart people. This is a really cool Prezi. It's about like how how if you only had a few tools and you're playing blue versus red, and you're dealing like with an intelligence organization like the NSA. This is just kind of an example like how these guys kind of bootstrap and play defense against very sophisticated actors, or kind of the model of the threat actor is kind of very high level. And so there's a few kind of tools in that sense. I think Monowall, IPCOP, Untangle, PFSense. These are all sort of great examples of other things you can use sort of in the spirit of some of the things we're talking about. But I think none of these are in the stack yet. And so, okay, so here's sort of the key, I think, kind of behavioral model that we're targeting with sort of Chiron. And one of the challenges with these type of architectures is kind of like how to programmatically evolve learning, or really what we're kind of building in code is the ability for our software to adapt. And adaptation is a super hard problem to like program. Our wetware has given us about 1 trillion years of data, or a few billion years of data for the problem of adaptation and survival and sort of like unbounded variables. But there is sort of a model of kind of computational learning that gets a little kind of computer sciencey, but at the heart, we have to sort of understand what it means to when you kind of build systems that are dealing with kind of like adversarial behavior. You have to understand kind of programmatically what it means to weigh new data versus old data. Like when should my system forget? When should it remember? These are all questions we have to answer in code. And so there's a stabilization algorithm kind of defined in the background that sort of kind of models these questions. And that kind of learning is all about kind of targeting a couple of these tactical use cases. I think that the most low-hanging fruit in my mind is kind of like use case A, which is about new service interaction in our LAN. The other one that I think scares me a lot is like Rod mentioned, is just our sort of perimeter kind of defense being popped. I think for the home, it's really kind of a scary like proposition. Like we would talk to like blue teamers, kind of like military blue that would their first job when they pen test a kind of a high profile organization, they buy all the hardware at the perimeter and they reverse engineer it and drop a 0 day on the Palo Altos. It's like the perimeter is very exposed, and so I think this is one of my favorite problems to think about in the context of the LAN for small businesses and home networks, because it's a lot easier to sort of study because there's just less interaction. We also kind of have this last use case. This is sort of like a freebie we threw in there from the junk drawer of code because we had a bunch of code already sort of targeting this. This is a little bit of an old problem, so I think the behaviors have changed. But anyway, we kind of threw it in there because it was sort of easy to blend. Anyway, so I think the other key, and this is sort of kind of how I assess sort of like maturity, organizational maturity from a security perspective. In some sense, is not only is it about like kind of having an understanding of your threat surface and kind of all the vulnerabilities that are implicit in an extremely complex technology stack, but also modeling our adversary. And having a model of the adversary kind of helps us understand, like, what are the classes of things that are in scope and what is out of scope. Like, I would never expect Chiron to catch like NSA red team, for instance. Like that's a model of the adversary that just like let's punt that problem to something more sophisticated. And usually there's a certain class of adversaries that just takes humans to defend against. But I think we can kind of target a couple. The one that I don't know. It's fun kind of like learning all this stuff like in when we're kind of digging through the data, because one of the ones that just wasn't occurring to me until Rod and me started working on this stuff was the opportunistic neighbors, especially after that Wi-Fi crack. So there's just a certain class of problems that I think are nice in scope for the home, and maybe what we want to sort of bound our scope at is like let's say we can kind of catch certain kinds of crime or ransomware with these techniques, and focus on some of these other things too. Kind of getting back into this model of the adversary, and I think sometimes we have sort of different permutations of these slides. Sometimes there's sort of a different one that it's a little bit more about like the limitations of machine learning. In my model, in my mind, sort of like as you go up in sort of sophistication of the adversary class, machine learning techniques become less and less like useful. And so I think you kind of have to have this sort of breakdown of the cross sections, and this is sort of how we sort of were kind of thinking about kind of the key behaviors, where we can kind of plug simple things in, and then maybe augment with one or two sort of advanced use cases. Yeah, so here's the key intuition. Anomalies on rare services and rare behaviors not in the last 30 days. That's kind of the thing we want to model in. And I wonder if these slides are a little... did these slides get messed up? I was having trouble seeing this, actually. Can you guys even see the architecture? Maybe if I put it in presentation mode. Okay, yeah, so I think some of the slides are a little bit, like, there's something going on. But anyway, like, I think just we'll skip over a couple things and kind of dive into the architecture here. Sorry, so if you kind of, like, this is online, you can download the slides. They render a lot better, like, just for whatever reason, this is kind of hard to see. But basically, there's, like, the architecture is kind of broken down into a few key workflows. The input kind of is defined here. Right now, we're using POF, Nmap, and Bro. We have sort of a kind of like a cron-driven workflow. This is just all on a VM. And what that cron job will do is sort of like cycle the data. Some of this stuff we have to run tactically. Like I don't know what the cron schedule is for Nmap, but we're not doing this stuff all the time. We're sort of limiting the data footprint and kind of being smart about how much we can kind of ingest in these next upstream workflows. But
so one of the things that I found when I was testing on my cable coder. You know what a cable coder is? It's a person that basically doesn't use cable. So I get the deal with the internet. They force you to buy a cable box, so I grab the cable box and throw it away. So what I have is Fire Sticks or Chromecasts. And I was getting in excess of 5 to 6 gigs per day of logs. So it's almost like big data for home. And at one point, our idea was to have a 1 gigabyte RAM, 4 gigabytes hard drive for this thing. So maybe it would run on a Raspberry Pi. Come to realize we need at least 4 gigs of RAM and at least 60 gigs of hard drive. And even with that, then I had to run you guys, maybe some of you are familiar with EOK. You know what Curator is? Okay, so I had to basically get down and dirty with Curator, because Curator would eliminate some of the indexes, because then, and I had to say this, and if there are splunkers here, they're going to have a laugh right now, but EOK breaks a lot. It breaks a lot, like constantly. The one? Yeah, that would be a nice way of putting it.
You'll also eat any remedy.
Right, that is correct. So dealing with EOK, and that doesn't help, or grandma, to try to make this for grandma, that doesn't help us. That does not get us closer. But unfortunately, there's nothing else unless we try to develop it ourselves, and I don't think we're there. We do this in our spare time, and we've been graciously supported by Greg Martin, and maybe someday, maybe we'll go product-wise, and we do a Jask for home, for example, but right now, this is the best we can do. I can tell you that we had a person from Hack the Valley, which is a hackerspace that me and Joe funded in Sunnyvale, California. And this guy went and segmented all his company's networks and put one of these. And he told me that the limit is about the same limit that I had on my test, 5 to 7 gigs. After that, you're in trouble. So you had to get on Curator. But that's a problem because, as Joe was saying, then we had to shorten the learning time. We shortened the learning time, and that may, give a window of opportunity to miss detection, right? So I'm not sure if you have any...
Yeah, I think that's kind of just kind of to your point, the bleeding nature of open source is kind of a challenge in this regard, So we kind of use what we were sort of comfortable with to sort of solve some of these other problems that are kind of auxiliary to the key use cases, particularly like how do we get a dashboard visualization, without writing our own GUI, kind of these sort of simple things about kind of how we sort of collect and represent all the data. And so yeah, ELK was sort of like a like a kind of a just sort of a necessary evil in that regard.
Right. Our idea was actually to put it on Security Onion.
Yeah.
That was our objective. But as we started developing it, we realized that was not going to be possible. Yeah, it's too big. Right.
Yeah. Yep. So I think this stuff's all online. So if you're really curious about the architecture deep dive, like you can kind of download this, and it should render better on your machine. But basically, this is just sort of there's two kind of architecture slides. This is sort of the high level data flow. Kind of data comes in here. We have a little cron job that's sort of breaking up different phases of ETL, and then based on kind of this data flow, there's one place where we sort of plug in a little bit kind of more advanced of an analytics machine learning use case that's based on this Action exploit detection. And then other than that, it's sort of all about this sort of like tactical, intelligent, rotational logs and some of these other problems that become kind of just the nature of like managing a lot of kind of heterogeneous data flows. I think this was the slide you already showed. This kind of doesn't render very well, but this is sort of like one step. I think this is phase 2. This is essentially our ETL phase, and kind of like how there's just all these little sub problems you got to solve. You got to kind of understand the identity resolution problem. That's sort of what's kind of happens in step 1. There's statistics we built, just basic stuff, top end, and sort of how we kind of write it to disk and kind of get it to the next step in the architecture. Okay, yeah, so here's kind of where we can, I think we have another repo since these slides were made.
Yeah, I think there's a JASC.
There's like a top level.
Yeah, it's also the JASC, but you can actually download it from there. I created an OVA, and I created a VMware. I'm thinking about maybe a Vagrant, but I'm not sure Vagrant will work for this type of setup. But you can give it a try. Please give it a try. I'll show you now. If you guys already took pictures of this, I'll show you the interface.
Are these still the right specs, Rod, for the recommended?
Yes, those are the last what we did for alpha. And here's an example. Here's an example of Chiron. Basically, what we try to do is make it easy for the user to understand it and to visualize it. But if we go here, you will see that's the current flow of data, right? It wouldn't be realistic because obviously I'm not it, and I'm trying to put it here for you to see. But then from here, you can always build, if you're familiar with ELK, you can actually build visualizations. And then we can look at things like this, for example, like the top IP addresses. We can look at services. Obviously, let's see if we can do year to date. This is probably a new machine, so it doesn't have much data. But you can, let's go back to the dashboard. In the dashboard, you can combine it, and here's how it looks like. So these are the IP addresses at home. Obviously, we would likely look at RFC 1918. Which ones are the most active? These are where are you connecting to? Here is where the Nmap stuff comes in. So then we can see things such as operating system. As you can see, there's iOS for phones, for example, Mac OS, Linux, and then sometimes a lot of operating systems I had no idea. I'm assuming that a lot of those are IoTs. Maybe this Fire Sticks or Amazon Echo Dots or Google AI.
Do you know what this IP is? This is your home network?
Yeah. Yeah, that's my home network.
It's a chatty Cathy right there.
Yeah, it may have been the laptop, I don't know. But and here are the ports, as you can see, the most active ports. We actually been doing some research on IoTs at our employer, and it's interesting how this AI things they are very verbose, very verbose, and then they start pinging until they can ping their own DNS. I noticed that Google is crazy. We were looking when we were doing we were trying to we're trying to work on dynamically discovering assets, and IoTs are now available of the entire enterprise network. And when you look at this Google Homes, it's almost like it's like a script. It starts pinging everywhere, and then you can see it finally sees it, and then I actually noticed that it discovers your DNS. Like I started seeing communication with pinging the Comcast DNS, and then it pings 8.8.8. And I'm like, this is not me. I'm not doing this, right? So this is obviously a new frontier. We don't know what's going to happen with these things, and I suggest you to do it at home. Put Wireshark, talk to your AI, and see how verbose is, how it goes back and forth, talks to the big AI backend, and then comes back and give you an answer. But there's a lot going on, and we do want to tap into this. We want to add Kismet at one point. We want to add Bluetooth at one point, maybe Ubertooth. But as we add this, obviously, then there are ETL issues. If you're familiar with big data, you will know what ETL is. And it's basically 3 letters that mean you're not going to sleep. Right? ETL will break your product. That's it. ETL will make or break your product. So please give it a try, and let us know if you add stuff, or if you decide to put it on an enterprise or on a small business network. Please do it and let us know. And if you have questions, then we'll be glad to take them now.
Does the actual package require you to have a separate installation of Bro, or
No, it comes with everything ready. You download the OVA or the VM, you turn it on. If you want to bridge it, even better, right? Then promiscuous, it's going to ask you to escalate. It's going to ask you for a password so they can go promiscuous, and then that's it. That's all we need to do. Just let it run for an hour or two, and you'll find stuff like this. Any other question? Yeah.
Yeah, so if I heard you right, the tool's written in Python, right? And you're using for the machine learning module also in Python?
Yeah, you can explain the down.
Yeah, I mean, there's sort of one supervised learning classifier that I think is a pickle file at this point that you import from our old. I mean, it's all sort of built into the workflow right now, but it's just from another repo where we originally built a Java-based project to detect exploits. We ported that to Python a year ago for a Black Hat project, and now we just kind of fit in nicely, so we just kind of threw it in there essentially. And that was originally, we just improved upon that sort of problem, in terms of supervised learning. We originally used a random forest thing out of scikit-learn. It didn't have, I think accuracy was anywhere from 70%. Now with a TensorFlow-based convolutional neural network, we're at 94% accuracy on I mean, the number of exploits we have labeled is around, it's less than 1,000, and we have hundreds of thousands of benign samples. So in machine learning, we call this a class imbalance. It's very typical of security problems. We don't usually have a lot of one of the malicious class, but it's a nice proof of concept.